All right, 7th graders. Today we're going to focus on adding integers and being able to add 2 or more integers without a calculator. This is a skill that you will carry throughout 7th grade and beyond. You want to be able to add positive and negative numbers relatively easily in your head. So we're going to practice this in multiple ways over the next few days. Today we're going to kind of get back to the basics of adding integers with tiles and just trying to see the visual of what is happening when you are adding integers. And I'm actually going to change the color of these tiles. Positive can usually be denoted with a yellow when you're talking these tiles. And when you talk negative, to be in the red is to be negative. So when someone says your account is in the red, that means that it is negative. You owe money. You don't have enough money in your account. These problems can be found in the integer note packet, so make sure that you have that and have that open to complete with us. So if we start with just kind of the basics of what you did when you were younger, if you're looking at these, you have 2 plus 5. And if we look at the integers, they're named by the sign in front of them. So in the case of the 2, that would be represented by 2 yellow chips. And in the case of the 5, that would also be represented by yellow chips as well because they are both positive. Now, one of the things that we have to know is that if we have a yellow chip and a red chip, that's like a positive one and a negative one. Sorry about that. Positive one and a negative one. Do you know what happens when we put a yellow and a red chip together? Well, that actually makes a 0 pair. So that means that these would cancel each other out. When I look here, do I have any 0 pairs? Nope. So I simply would just count how many chips do I have, and together I have 7 yellow chips, which means 2 plus 5 is 7, which I know you know, but we're just looking at trying to be able to represent that with chips. So how many chips would be represented by this first number? And what color? If you said 7 yellow, you would be correct. So I have my 7 yellow. And then how many are represented by this next number? And what color? And if you said 2, you'd be correct. Are there any 0 pairs that cancel each other out? Nope. So if we count them, 3, 6, 7, 8, 9, we know that 7 plus 2 is 9. All the chips are the same color. As basic as it is, it's giving you a visual to help you understand integers. What's a little different about number 3? If in number 3 you said, well, now the chips have become red because they're negative, you would be correct. So I'm starting with 8 negative chips and then another set of 3 negative chips. Do I still have any 0 pairs? Nope, because I don't have a combination of red and yellow. So again, these wouldn't cancel each other out, so I simply count how many chips do I have, and I have 11 chips. So altogether, negative 8 plus negative 3 is a negative 11. I'm combining all those chips together. 4 is a similar problem in that you would start with 6 red and 2 red. Again, they're all the same color. You're just putting a bunch of negatives together. So your answer would be negative 8 because that's how many chips you have total. Okay. Now in 5, you're going to see now we can start to combine positive and negative numbers. So the first 7 is going to be represented by, remember, yellow chips, 1, 2, 3. And then the second one is going to be represented by red because it's negative. Now I'm creating 0 pairs. A positive 1 and a negative 1 equals 0. And if I go through this, I can see that they cancel each other out. So if I have 7 yellow and 7 red, and I combine them together, that really equals 0. Kind of like having $7, and then all of a sudden you owe your mom $7 for the latest candy you bought at the Dollar General. Now you're down to 0 money. Okay. How about a number 6? How are we going to represent the 3? If you said 3 red, you'd be accurate. And how about the 8? Now on this one, the 8, the sign that names it is this positive, so we're going to have 8 yellow. Now I look for my 0 pairs, and when I cross out my 0 pairs, I will see that I no longer have them all eliminated, but I have 5 yellows left over. And if I have 5 yellows left over, that means my answer is going to be a positive 5. All right? You do not have to put the positive in front of it, but I'm just using it to help you kind of think about a little bit more the sign of the number. Okay? In number 7, what are we going to start with? 4 red, and then 5 yellow because the 5 is positive. Cross out your 0 pairs. How many 0 pairs are you crossing out? And I'm left with 1, and it is yellow. So because it's yellow, my answer would be a positive 1. Okay. How about the 8 plus a negative 9? What am I going to start out with? 8 in what color? Yellow because it's positive. And then what about the 9? The 9 would be represented by red chips. And now if I cancel these out, all my 0 pairs, there has to be 1 yellow to go with 1 red. And when I do that, I'm left with 1 red, so then my answer of 8 plus a negative 9 would be negative 1. Okay? Go ahead and just maybe try page 2 in the note packet and see what are you able to come up with as solutions for each of these, and visually see kind of what's happening when you have chips that are the same color versus when you have chips that are 2 different colors. Right. Hopefully you gave that a try and kind of are visualizing it. If you take a look now, I'm going to just take what you got from above the answers, and then we're going to start to kind of look and see what we can discover from the pattern. So if you were looking at number 1, you would have discovered that the chips canceled and you were left with a positive 1. In number 2, you were left with a negative 1. 3 was a negative 9. 4 was 9. 5 was a positive 1. 6 was a negative 1. 7 was a negative 5. And 8 was a positive 5. Now, if we look, we really had 2 different types of problems here. This is where we're trying to kind of really devise what is the rule that we're going to use when we're adding and subtracting. Well, if I take a look at 3 and 4 and 7 and 8, what do you notice that these ones have in common versus if I were to look at 5 and 6 and 1 and 2? Hopefully what you're kind of starting to discover is in these ones that were boxed in yellow, notice that the signs are the same. So I've got 2 negatives or 2 positives in each of them. And when I did that, what did I do with the numbers? If I thought about the absolute value of the numbers and didn't even think about their signs. Well, all my chips were the same color, so I added them together. So notice that when these signs were the same, I simply just added the numbers and then took the sign of the numbers that I were combining together, or took the sign of the colored of chips. Whereas if you look at the red, what do you notice about these 4 problems? They all have 1 positive and 1 negative, so they've got ones of different signs. And when you did that, what did you actually do with the numbers themselves? Not thinking about the sign attached to them. Well, if you started to see, well, I really subtracted 5 minus 4, you would be correct. You actually subtracted the numbers when you had chips of different colors because you were canceling each other out and you wanted to see how many 0 pairs you have and what was left. And then your sign was determined by which one you had more chips of. So here you had more yellow, whereas here you had more red, so your answer was negative. Okay. Let's take that now and put it into our adding integer notebook. So we noticed that if we were adding 2 positives or 2 negatives together, then you simply are going to just add the two numbers together. And the answer takes the same sign as the numbers that you are adding. So my example here is I have a -5 and a -9. Notice that the signs here are the same, so I'm simply going to just add what's 15 plus 9. 15 plus 9 is 24, and because they're negative, then my answer is going to be a -24. Okay, so if the signs are the same, we're going to add them together. Whereas if you are adding together a positive, so just one positive, and a negative number, so different signs here is key, then the numbers you are going to actually subtract the two numbers. The sign is determined by the number with the greatest absolute value, because that's the one you're going to have the most chips on. That's the one that is going to be furthest from 0 on the number line, so you're going to be having more of those numbers. So if I look at my example that they give here, in the first one you have 13 negatives and you have 9 positives. If I cancel out the 9 positives with the 13, I'm going to be left with 4, because 13 minus 9 is 4. And because there are more reds, then my answer is a -4. Whereas in the other one, it's kind of the same thing, only the signs are reversed. This time I'm still going to subtract because they're still going to cancel each other out. I'll still have 9 to cancel out the 13. But this time I have more of the positives, so my answer would be a +4. So the big thing in adding integers is to look at the signs. So we're going to focus on the signs when we are adding them, and you're going to see that I added the tip of circle them. This is not only going to help you with integers, but it's also going to help you when we get into algebra and simplifying expressions. So I'm going to give you some points for circling accurately, because you're thinking about the sign that names the number. So here I've got a -19 and a -9. Are the signs the same or are they different? Well, they're the same. You have the same colored chips, so you're going to add them together. And if you need to look back up here, you can look to see. If they're the same, I add. If they're different, I subtract. So because they're the same, I'm going to add 19 and 9. And 19 and 9 is 28. And they're all negative, so then my answer is going to be negative. Okay? Here the signs were the same. Now here I've got a 24 and a -8. The sign in front of the number names it, and if there is no sign in front of the number like here, we assume it's positive. Now here the signs are different, so I'm going to subtract. 24 minus 8 is 16. Now I have to think about my signs. Do I have more positives or more negatives? I have more positive chips, so my answer would be a +16. Again, you don't have to write that plus, but I'm just helping you to make sure you're thinking about the sign afterwards. In the next one, I have a +12, and I can really use this +14 or the plus in front of it, because I'm just taking 12 chips that are yellow and 14 chips that are yellow as well. So I'm combining them together because the signs are the same. I'm going to add, and so my answer would be 26. And a +26 because they're all the same color. They're all yellow. And the next one, I have a -32 and a +5. Notice how I'm circling the number with the sign. The signs are different, so I'm going to subtract. 32 minus 5 is 27. Do I have more positives or negatives? I have more negatives, so my answer would be -27. Okay. I'm going to continue. I've got a -15 and a +7. The signs are different, so I'm going to subtract. 15 minus 7 is 8. And I've got more negatives here, so my answer would be -8, because 15 has the greater absolute value. You're more on the negative end. I've got a -22 and a +8. The signs are different, so I'm going to subtract them. 22 minus 8 is 14. Do I have more positives or negatives? If you said negative, you would be correct. Okay. If you want to pause the video at any time and try some of these, I think that'd be a great idea for you to pause and try them and then see if your answers agree. So going into the next one, I've got a negative 20 and I've got a positive 20. That parenthesis around those are just holding the signs next to it or no sign at all. They're not really needed there. So I don't have to be worried about the parenthesis around this 20. It's just holding that number. Here the signs are different, so I'm going to subtract. And when I subtract them, they cancel each other out, and the answer is 0. Okay. Again, these parentheses are just holding that negative sign next to the number. So I've got 2 negative. The signs are the same, so I'm going to add. And when I add them together, I get 46, and they're all negative, so it'd be negative 46 because all of the chips are the same color. Couple more. Negative 15 and a negative 4. The signs are the same, so I'm going to add. That's 19. They're all red, so I'm going to make it a negative 19. Number 10, I've got an 11 and a negative 21. The signs are different, so I'm going to subtract them. 21 minus 11 is 10. I have more negatives. 21 is larger and it's negative, so my answer would be negative 10. Now, when you have more than 2 numbers, if you see an 11 and 12, you just have to do it in a 2-step process. And really, remember that that adding is commutative. So you could do it in whatever order you wanted, which is important for you to show your work as well as circle the signs so I know what you're adding. So like when I look at this one, I'm going to start with the 2 negatives. So I've got a negative 7 and a negative 3. The signs are the same, so they combine to a negative 10. I'm now going to simply bring down the positive 4. And now I'm going to circle, I've got a negative 10 and a positive 4. The signs are different, so I'm going to subtract. And if I subtract them, I get 6. And there's more negatives, so my answer would be negative 6. But I could, if I wanted, just go left to right. So in number 12, if I want to do a 5 and a negative 20, the signs are different, so I'm going to subtract them, and I get 15. And there's more negatives, so it's negative 15. I bring down the plus and negative 10. And now if I look at the signs, I've got a negative 15 and a negative 10. The signs are the same, so I'm going to add them together, and I get 25. I'm adding 2 negatives, a bunch of red chips together, so my answer is negative 25. Okay. Thank you for listening through those notes. We now have some practice to do related to adding integers. Remember to circle the signs and always look back at your notes if you need to remember when do I add and when do I subtract. In fact, you could even write them at the top of your notes if you needed to. All right? Thank you. Have a great day.